Lesson 70, probability. Terminology first. When we're talking about probability, we're talking about events that might happen any one of a number of different ways, like flipping a coin or rolling dice. Each time that we do one of these, when we're talking about probability, we call an experiment, one action of doing one of those things. The result of that we call an outcome, the outcome of our experiment. And anytime that we do an experiment, there are always certain outcomes that are possible and certain that are not. And the possible outcomes we call our sample space. This is a set, it's a group of possible outcomes. And when we're talking about probability, in order to approach these from a mathematical perspective, we need to be talking about things that are equally possible. Otherwise, you're going to have to make your math a lot more complicated. But so, for example, when we're flipping a coin, your sample space is heads and tails. Those are your possible outcomes. If you're rolling a die, you've got 1, 2, 3, 4, 5, and 6. For any particular event, when we want to know its probability, the way we calculate that is by taking the number of outcomes that satisfy the requirements and then divide it by the total number of outcomes in that sample space. So for example, if we're looking to roll a 4, then that's one possible outcome out of the 6 possible outcomes, so the probability is 1/6. There could be more than one outcome that satisfies the condition. For example, if we want to know the probability of rolling a die and we get something that's more than 3, there are 3 outcomes, 4, 5, and 6 in that sample space that satisfy that condition. So 4, 5, and 6, that's 3 outcomes out of the 6 in the sample space, or 1/2 is the probability of that happening. Our probability, because of this, it can be anywhere from 0, which is something that's not possible. So if you roll a normal die, what's the probability that you get a 7? 0. None of those 6 possible outcomes get you a 7. So our probability is 0 out of 6 or 0. Or it can go as high as 1, something that's definitely going to happen. For example, if flipping a coin, you get either heads or tails. That's both of the possibilities in that sample set, 2 divided by 2 or 1. We'll usually be expressing it as a fraction, but you could also see it as a decimal or a percent. So you could express something that's got a 1/2 probability. You could represent that probability as 0.5 or 50%. But our probability can't be less than 0 because 0 means it definitely won't happen, and it can't be higher than 1, meaning it definitely will happen. Independent events. Independent events are ones where our outcome doesn't affect our future outcomes. So flipping a coin or rolling a die are both good examples of this. No matter what you get when you flip a coin, the next time you flip it, there's still 50-50 chance of it being heads or tails. So looking at it with dice, we roll a die. The first 3 results are 4, 2, and 6. What is the probability the next roll will be a 3? Now we can just ignore those first 3 rolls because they have no bearing on our one roll that we're wondering about. So we just do this like we would do any other probability. There are 6 possible outcomes for that 4th roll: 1, 2, 3, 4, 5, and 6. They're all equally likely, and one of them will satisfy our condition if it's a 3. So for our probability, we take that one outcome that satisfies it, divided by the number of outcomes in our sample space, 6. 1/6 is our probability. You could express it as a percent, 16.6 repeating percent, or decimal, 0.16 repeating. But 1/6 is going to be easiest. Another example, if we roll 2 dice, what is the probability that the total of the 2 dice is less than 6? Now here our sample space is going to get a bit more complicated because we've got 2 dice. But notice that what happens with 1 die doesn't actually affect what happens with the other one. So we'll see there are 36 possible outcomes here. So this sample space here, I've written it as a chart. Along here, this is what happens on the first die, and this is what happens on the second die. And so our sample space is what's in here. These are the possible sums of the 2 dice, right? Because we're asking about the total of the 2 dice. So they could both be 1, they could both be 2, we could have 1 and 3, we could have 3 and 1. It doesn't matter what we get on this die. This die could still be anyone from 1 to 6. And when we add these totals together, we see these are all the possible outcomes. And I've highlighted the ones that are less than 6, and we can count them. There are 10 of them. And so for our probability, it's 10 divided by 36, or 5/18. is our probability there. What if we have independent events that have to happen in a particular order? So you notice with that last one, it didn't matter, for example, if we were trying to get 7, it didn't matter if one die had a 3 and the other one had a 4, or if the first one had a 4 and the other one had a 3. Those both would have satisfied that. But what if they have to happen in a particular order? You know, the first die roll has to be below a certain amount, and the second die roll has to be something else. When we have independent events that happen in a specific order or designated order, we multiply together the probabilities of each of the events. For an example, to demonstrate to you why this works, what's the probability that a coin comes up tails, then heads? So there's only one thing here that satisfies. It has to be tails first, then heads. Well, we could think of it like we did with the previous problem. There are 4 possible outcomes if you're doing 2 coin flips. Heads, then heads then tails then heads, or tails then tails. One of those, tails then heads, will satisfy our condition. So 1 divided by 4, or 1/4. We could also do it by taking the probability of the first flip being tails, which is 1/2, and then the second flip being heads, which is also 1/2. So the probability of those happening in that order is 1/2 times 1/2, or 1/4. Either one of those will get us the correct answer, but the only reason we were able to make this simple sample space here is because we were dealing with something pretty straightforward, 2 coin flips. If we had something more complicated involving multiple rolls of dice, it would have been very difficult to write out a whole sample space like that. So you want to calculate the probability of each event separately and then multiply them together.